Hey everyone, and welcome to Bitstream. Today we'll be looking at parametric design and 2D constraints in Autodesk Inventor. And so, let's get started. I'm going to pull up a new part. And let's go ahead and start a new sketch. And then we'll go ahead and click the XZ plane, do it from the top. And I always orient it upward, OCD kind of thing. And the way this is going to work is I am going to do the design in a more relaxed way, and then we're going to use constraints to make it all perfect. So here we go. So the first thing you're going to want to do is click on the little equation symbol right here, and this opens up your parameters panel. And I use this quite a lot. In fact, most of my designs I parameterize pretty much every measurement. And so let's go ahead and put the outer boundary in there, and let's just say this cookie cutter is going to be is 4 inches in diameter. Okay, so we're going to say 4 inches. Yeah, and so the first one is the name, and then you have the unit/type, and if you click on that, you can click any one of the options. There's a lot of them. If you're gonna do unitless, which means like if you're just counting something, we'll get to that, but that's just UL. Okay, so we have the outer boundary. And then we're going to do the inner boundary as well. So I'm going to show you the snowflake that we have going here. So this is going to be what we're going to create, maybe a little better. And so the outer boundary is this part right here, is the outside part. And so this is how big the cookie will be essentially. And then the inner boundary is where the spikes of the snowflake stop. Okay, we're going to do the inner boundary, and let's just say 2 inches for now. Okay, so let's go ahead and go with this. So what you're going to want to do is click on the construction line and then a circle. So go ahead and place that point and expand that out. And then here, this is where you're going to type in your parameter. And so we're going to do outer boundary. Okay, so it created that, and as you can see, it's not in the center where we want it to be. And so this is where we're going to use our first constraint, the coincident constraint. And so this is good for putting a point on a line or a point on a point. And so we're going to first click on the constraint, and then the center of the circle and the center of our sketch. So that's going to put that in. And let's go ahead and put our second circle in there, and it's already got the construction line. And this one we can just stick right there, and that'll automatically put that constraint in. And we'll do the inner diameter, or the inner boundary. Okay, so we have this to work with. Now, one thing that I also want to do as well is do the number of I'm going to say spikes. Can't think of anything else right now. The number of spikes coming off of the snowflake. And let's have that be 6 for now. So spikes, and then this is where it's going to be unitless, like I was talking about earlier. And then let's just say 6. Okay, so 6 UL. We'll go ahead and click OK on that. And the reason we're doing that now is because what we're going to do is we're going to design one spike of the snowflake, and then we're going to replicate it in a circular pattern. Okay, and so we're going to need to know our boundaries for that. So let's go ahead and put some lines in. So there's that construction line, and this will stay construction. And we'll do a second line here. Okay, and so we're going to use the coincident constraint again to put this in the center and this one in the center as well. Now, also what we're going to want to do is make it so that these lines are also touching this outer circle here. So I'm going to click that and then click the circle. And so that forces the line to stay on that circle. We'll do that with the other one. And of course we're going to want to make the lines the same angle apart. And so what we can do is we can do the symmetric constraint. So these will be a little out of order, but hopefully by the end we'll cover all of them, or most of them at least. So I'm going to click the symmetric constraint, and what you're going to do is click the first line, the second line, and then we're going to need something to symmetricize it around. And so let's go ahead and go to our origin here, and then hover over the correct axis. And so you can see those popping up here. And the axis that we're going to want is the z-axis. So I'm going to do that. And so after doing that, and then you can click escape to go out of the symmetric constraint mode. If we take the tip of this line, as you can see, when we move it, the two lines stay symmetric with each other. Okay. And now we're going to want to put an angle here so that when we duplicate it, there's going to be the correct angles for the number of spikes we have. And yeah, I'll just I'm going to rename the parameter here number of spikes, but you can name it whatever you want. Okay. And so we can do equations. So you can do equations both in the place where you put the normal measurements, as well as when you dimension something. And so we're going to do a dimension between these two lines here. And then we're going to say for our equation, so 360 degrees divided by the number of spikes. Okay, and so that constrains it to 60 degrees there. And yeah, so I'm going to escape out of the dimension tool, and I'm going to move that more out of the way so that we don't have to worry about it. Okay, and so what you can see here, where I'm moving my mouse, is the area that we're going to be working with. And so the first thing that we're going to want to do is let's put some, let's start off the spike here, and we're going to take off the construction line. And so if we see that green dot right there, that's going to constrain that point, the starting point of our line right there automatically, so we don't have to use a coincident constraint. So let's go up to around here. And then another thing I want to add as well is just a little extra spindle coming off of the end. And so we're going to put this right here and come up and then over to the line. So hopefully we can just mirror this. And so we'll just be working in this space right here. Okay, and as you saw from the picture as well, there's a semicircle there. So let's go ahead and put an arc in. So I'm gonna just put it lazily right here so that we can put in our constraints. And so I'm going to constrain this point to the line and this point to the line as well. And then we might as well put this point on the line. And so that'll make sure that it's exactly half of the circle that is on there. And things aren't really constrained right now, but we'll work on that. And one immediate thing I want to do is, this is going to create problems right here, having this line and that right there. So I'm going to split the line in the modify tool set, and split the line here and here. And then what we can do is we can select this part of the line and make it a construction line. I don't generally like to delete it because sometimes that can mess up certain constraints and measurements and things. Okay, So this is looking fairly good right now, although, oh, we have a problem. So as I move that around, you'll see that this line right here is no longer in line with that. So this is the perfect opportunity to use the third constraint here, the collinear constraint. So we're going to click that, and what that does is when you click on these two lines, it makes sure that they are lined up with each other. Okay, and you know I was talking about that spindle at the end? Let's go ahead and put that as one of our parameters. The spindle length. And for now, let's put half an inch. And click done. So when we dimension this, I'm going to dimension this to spindle length. Okay, so that did create some interesting things here. I'm just going to move this down here. And we also don't want this to go above the circle. So we're going to do another coincident constraint. Click on that point, click on the circle. So that'll make sure that when we move things around, it doesn't go beyond the circle. And while we're at it, let's go ahead and put this circle in the center between these two lines. And so the perfect constraint for that is the equal constraint. And what that does is it makes things equal in length. And so we're going to click on the first line, the second line, and so that forces that circle to be exactly in the center between that. And our snowflake is going to look a little squished, so let's take that spindle and make it a little smaller. And so I remember the parameters thing is in the F button. Okay, so the spindle length is going to be, let's do 0.1 inches. Usually I like millimeters, but for this, we'll stick with this. Okay. And so now I think, oh yeah, we also don't have a spindle width. So we'll put in the spindle width as well as the size of the circle. So you can see what's not constrained by trying to move things around, which if you really mess things up, you can always hit Control Z. So we'll put the circle size in there. And let's make that half an inch. That actually might be a little big. Let's do 0.2 inches. See what happens with that. And so this is going to be the radius. So let's go ahead and hit the dimension tool right here. And then circle size. Okay. That looks pretty good to me. Let's make that inner circle a little smaller because I feel like it's going to be a little squished. So our inner boundary I'm going to make 1.5 inches. And as you can see, if I say 2 inches and 1 inch, things update accordingly. So yeah, 1.5 inches. And something interesting you'll notice is this end actually was not constrained to these 2 points. So we're going to go ahead and do that. So constrain that point to that circle. So I misguessed on how it's constrained, and so it said it's going to over-constrain it. So let's just see. Okay, it doesn't look like we can move this circle super great. I removed that point. And so what you can do is you can actually delete constraints if something's a little over-constrained is what it's called. And so when you click on that, there's multiple ways of doing this, but you can click on it and it'll show that that it is constrained. Oh, that's why. Okay, so it's constrained to the midpoint of this line. And so I'm going to, so you click on it and then right click and then delete. So that deletes that constraint. So we should, yep, we can now move around this line. And before we do that, I don't want to mess things up too much. Let's do the width of the spindle. So I'm going to click the parameters button again, add numeric, and then let's say the spindle length. Or no, we did the spindle length, the spindle width. And this one, let's just say, is 0.2 inches again. Okay, so let's dimension that. And so that'll be dimension between here and here. However, we have to remember that since this is mirrored, it's going to double in size. So we can go ahead and click, and then we'll say spindle width, and then have half it. So divided by 2. And that is a lot longer than I was expecting. So let's go ahead and oh, I meant 0.2 inches, not 2 inches, that's why. Okay, so now you see that updated live, and then now when we move this point, things are a lot more controlled. So let's go ahead and make a coincident constraint right here, and then let's also click the line and the point again, and that makes it nice and sturdy right there. Okay, so to make this look more real, let us do a mirror. So what we're going to do is click the mirror pattern and click on everything that is relevant to us. So that's going to be these lines and the half circle. And then the mirror line is already viewed. It's that it's the z-axis. So click apply and then done. Okay. So we have that. And something that is really helpful is this offset button. And so this is going to provide the thickness that we need for our cookie cutter. So I'm going to go ahead and offset this. Okay, so oh wait, before we do that, you can always click escape. I'm going to go to the parameters, and then I'm going to say the cut edge thickness. And I think a good cut edge thickness is let's do 2 millimeters. And the nice thing about this is you can mix up units, for better or worse. Okay, so we'll say offset again, and then click that, and then we can actually just type it in right here, cut edge thickness. Okay. So let's change the cut edge thickness to 1 millimeter. And as you can see, once I click 1 millimeter and enter, it will automatically update. So one problem that we have is these lines represent where the other pattern iterations are going to touch. So we can't have this right here. So let's go ahead and split it right there. And we can delete that, and we'll go ahead and do the same thing on the other side. Okay, so as you can see, this kind of broke one of the constraints here, but that's okay. We can fix that, and an easy way to fix that is by making it the same length as this one. So we can either make it equal or symmetric. I think I'll just prefer equal. So I'll click on the equal sign and click on this one. And that puts that back in place. And okay, so it still seems to want to move upward like that. So a good thing to do is, this is actually a perfect opportunity to use the parallel constraint. So this makes it so it's, well, parallel to any line. So let's parallelize this line and this one, and that constrains it fully. And when it's fully constrained, as you can see, it turns to a nice purple color. Okay, so when we extrude this, it's going to need to be solid, and everything looks good here, except it's open right here. So I'm going to go ahead and just add a line from here to here, and on the other side, the same thing. Okay, so let's go ahead and extrude it. So I'm going to finish that. And I'm going to extrude, and it automatically knows what to extrude because it's the only thing. And so I'm going to make it go downward, and then we're going to change how far down it goes. So I'll leave it at 10 millimeters for now, but let's parameterize this. So I'm going to go to the equation and say cut edge depth. And let's make this 1.5 inches. So we could double click the extrusion right here and type in the cut edge depth. And go ahead and click OK. Obviously 1.5 is probably a little too long. So let's just say 0.75 inches. Done. And it updated live right there. And so what we can do at this point is take a look at it, and I think I'm going to make that spindle width a little smaller still. And so spindle width, let's say 0. Let's do it in half, so 0.1 inches, and see, it'll update live right there. And it's a lot easier than having to go back into the sketch and change it manually. And that's why I love parameterization, is because as long as you do the constraints right, things will just update and it'll just work for no matter what size you use for anything. Okay, so now let's make the top of the cookie cutter, because this is just the cut edge. And so we're going to do a new 2D sketch and then click on this face right here at the top. And then we can actually continue using this design here, and we'll just project geometry and click on that whole face there. And then we will add a new parameter for I'm going to call it the lip. And so we're going to say the lip width. And then let's make that 5 millimeters. And then the lip thickness. And let's make that 2 millimeters. So we can use that offset tool again to offset the lip. So I only want the outer edge. So I'm going to escape, and actually I'm going to click that point right, or that line right there, and then make it a construction line, and we'll do the same thing over here, and we'll see if that works. No, it didn't. Okay. I mean, that's how you learn. You experiment. So the best thing that I'm going to do in this situation is I'm going to Control Z. So I'm going to undo to this point where we don't have the projected geometry. I'm going to say project geometry again. And this time I'm just going to go line by line for the inside part. And then we're going to do the offset. There we go. That's what I was looking for. And so here we're going to say the lip width. Or at least I thought that's what it was called. So I'm going to list parameters, and then, okay, I'm not seeing it. Oh, okay, it's because I Control Z'd. All right, undid. Okay, so I'm going to do the lip width again as 5 millimeters, and the lip thickness as 2 millimeters. Let's offset this again and say the lip width. There we go. Which that might be a little big still. So let's just say 3.5 millimeters. Okay, that looks more reasonable. And remember that line that we had before in this sketch? So you see that that it's still going over. So let's just recreate the line. So we click on line and then a construction line, and then we can click on this edge and come up. And then we'll do the same thing on the other side, like that. And so we want to make it the same angle as this line, which is pretty easy. We can just use that constraint that we learned earlier about with the collinear constraint. Constrain this to here. Constrain this to here. And so this is more of just an angle marker for us to know how long these lines should be. And so let's go ahead and split this, and we'll split this as well. Okay, and I'm going to click on these extra parts of the line here and click delete and delete. So these are now less constrained, and so let's make them symmetric. So click on the two lines and the z-axis, and at least they'll change together. But it's not the correct thickness, so we can go ahead and just click on dimension, and then we'll click between these two lines here. And actually, if for some reason it is wanting to do an angle, so let's see if it won't help to do a parallel constraint. It might give us a problem with that, but nope. Okay. So now that they're parallel, we can go ahead and dimension it. And so this is going to be the lip width. Okay, cool. And we might as well make these lines, those extra lines we need to close this up. So I'm going to use the coincident constraint and put it at the end of this point, and do the same thing for the other side. And then I'm going to click on each line and unselect the construction line. Okay, so that completes the lip. So I'm going to finish sketch and extrude. So it already knows what it's going to extrude. And this is going to be the lip thickness. Okay, and so we're at a point now where we can do the pattern that I was talking about. And so I'm going to click the circular pattern and select both the lip and the cutting edge. And then on the rotation axis, let's click the y-axis. And it already has defaulted a good number, but let's put in the parameter here so that we can change it. And so this is going to be the number of spikes. And it failed. So let's take a look and see what happened. Could not build the extrusion self-intersecting profile. Okay, so let's go ahead and cancel that and take a look at this sketch. Okay, so it worked that time. Not sure why it was having troubles before. But yeah, so now we have a beautiful snowflake cookie cutter. And I didn't use all of the constraints here, but yeah, I encourage you to take a look at those, and if they're put in the comments if you want me to make another video talking more about all the constraints, because it'll actually tell you about them and how to use them, and I encourage you to go ahead and experiment with those if you want, or I'll do another tutorial if you wish. But I hope that helped, and so let's go ahead and see what happens when we change some of these parameters. And it's I always find it really fun to to take a look live, like what happens. Sometimes it'll break it. You got to be careful. Yeah, if you if you underdo something or overdo it, then it can kind of break it, and it'll take a bit to get back. So let's do the inner boundary 1 inch instead of 1.5 inches, and put it at 1 millimeter, so that definitely creates a different design, but let's put it at 1 inch, and does that. And let's say the spindle width, let's do 3 millimeters. Actually, let's do 1 millimeter. Okay, so it didn't like that. That was a little too close. We can try 2 though. 2 millimeters works fine. And let's make the outer boundary. Oh, let's try something crazy like 6 inches. Okay, didn't like that. And that's what I was talking about. Like sometimes things just break. But as you can see, 5 inches, it's just fine with that. And then we can increase the number of spikes. Let's say 7 spikes instead of 6. And for some reason it didn't do that properly. So I'm going to take a look at the circular pattern. Oh, I didn't actually put that in there. Number of spikes. Okay. Yeah, and so this is just kind of the process of diagnosis and to see things. So now there are 7 spikes, and we can move that down to, like, let's say 5 spikes. Boom. Or even 4 spikes. And you get kind of a cross. Even 3 spikes. Now you get a ninja star. I'm going to move that up to 6 spikes again. And you can, we'll change the circle size to 0.5 inches. And that definitely creates an interesting pattern. Maybe 0.3 inches. Oh, that's millimeters. 0.3 inches. And so the really cool thing is that you can make a very customized design by having these parameters and constraining them correctly. So you can mess with these numbers for a while. Yeah, so that's that. Thank you for watching, and if you have any questions, feel free to leave them in the comments, and don't forget to subscribe if you like this, or if you like some of my other videos, go check them out. They're cool. And yeah, have a good rest of your day. Bye-bye.